Okay, let's go ahead and go through Chapter 7, Section 1. Uh, this is more along the lines of maybe just kind of just doing a lot of practice problems together, um, and just kind of just doing these problems. It's like learning them by doing them, I guess. Because, a lot of these equation problems, we're using inverse operations, and, there's a lot of kind of combined procedures that we kind of have to talk about as we're doing these problems, which I think helps. So let's just do a bunch of them. There's a lot here for section 1, and I'll just kind of go through them one by one. Feel free if if you ever want to stop the video and because you can do whatever you want, but just stop the video and do the problems on your own and just check them, see how you do. But that's what I'm going to do. I'm just going to kind of just do a bunch here and go through these. Now these particular equations are we're going to kind of focus on the principle of equality, which is the basic principle of algebra. It's the thing where as long as you do one the same thing to both sides of the equation, that you're kind of keeping the meaning of the equation what it is, because that's what an equation is. An equation is balanced on both sides. The right side equals the left side equals the right side. So as long as as long as you apply the same operation to both sides, and you're adding the same thing to both sides, or you're dividing the same thing to both sides, you're pretty good shape. You can always kind of fall back on that if you're ever lost. Like, hey, what do I do to solve this problem? You can always kind of just go, well, maybe I should just try dividing this to this side and that side, and seeing how that goes, and see what you're left with, and see if that helps. But yeah, let's just kind of do a few here. This first example right here is a basic kind of subtraction equation. So I always kind of focus on the variable side. That's the side I want to look at first. So I see m minus 6. So I'm going to add 6 because the goal is also of algebra is to get the variable, the x or the m by itself. We want to isolate it. And so we're going to add 6 to both sides. All right, and that's pretty much all there is to this problem. That basically is it. We just get m equals -6. All right, on the next example, this is another one-step equation where we have plus 40 on the m side. We have that on the letter side, on the variable side. We're going to do the inverse of that, which is taking away 40. So if we're taking away 40 on the left side, we're going to take away 40 on the right side. Okay, so those cancel off on the m side, on the variable side, and we have m. And then on the right side, notice we have -55 and we have -40. So those are both negative, meaning we're going to add those. We're not going to subtract. I mean, I know we're subtracting 40 from both sides, but we're really not going to subtract those numbers. We're really going to add their absolute values and keep the signs. So -55 and -40 makes -95. All right, and that one's done. Okay, keep going here. All right, we're going to add 13 to both sides here, because it's the opposite of -13 is adding 13. All right, those cancel off right there. And then we've got n equals -1. We have -14 plus 13, which leaves us with -1. All right, on D, kind of same thing going on here. Very simple one-step equation. Maybe the only thing that might be a little bit different on this one is that, it's kind of written in a different way, but, where all the stuff's on the right side of the equation, but don't let that throw you off. Some people, I don't know. I mean, I don't know. They just get kind of used to doing things one way, and they just rewrite it. They kind of like, I don't like it this way, and they'll write it x plus 12 equals 13. You can do it that way. There's nothing wrong with that. But, kind of adds an unnecessary step if you think about it. But we're just going to take away 12 from both sides. All right, so 13 minus 12. Get your calculators out for that one. That is 1. And so you get x. 1 equals x. All right. Moving along here. We're going to kind of fly through these. All right, we're going to take away 8 from both sides. I'm always looking at the variable side. Because the goal is, like I said before, the goal is to get x, or the variable, whatever that is, by itself. So we're going to take away 8 We're going to subtract 8 from both sides, or add negative 8. I guess you can think of it that way. And negative 4 and negative 8, that makes negative 12. So negative 12 equals x. Okay. The next one here, now this one has a little bit more going on. And you could do order, or not order, but you can do inverse operations. You could do that. But my recommendation, you probably hear this from a lot of math teachers, which is to, if you ever have, because we're focusing on the variable side, but if you ever have, if you ever have like terms, if you ever like terms that you can put together, or if there's anything that you can possibly simplify on one side or the other of an equation, do that, okay? Simplify it. Then I would make one of your last things that you're doing inverse operations. Although there is other, there's different routes you can take to solving math problems. You might be like, I don't have to do that. I can add 3 to both sides, and you're not wrong. But I just, I think it's just not a bad idea. So I'm going to put those together. Now, 4x and 3x, this just makes x. So I'm going to rewrite the problem. So we got x minus 3 equals 8. Okay, now we have a new problem. And now it's just a matter of adding 3 to both sides. Add 3 to both sides, and then there you have it. X equals 11. Easy, right? Easy. All right, next one. Moving on to example G here. Same thing as the last one. We've got a little bit of, we have some like terms that you can simplify. Do that. I'm going to rewrite it now. We've got 6 equals, and this, again, this equals 5y and 4y makes 1y, which is just y. You could put a 1 there, Put a 1 there if you want. That makes you feel a little bit better about solving that equation. Go ahead, but you don't need to. All right, and now it's just a matter of subtracting 2 from both sides of the equation. So what do we get? We get 4 equals y. All right, moving on here. All right, now this has got something on both sides of the equation that could be worked out. Now I'm going to kind of be a little bit messy here, but 3 squared is 9. Okay, I'm just going to overwrite that. I'm going to make that a 9. And then, all right, so this right here, that negative 9, or negative 40, sorry, negative 40 and 9, that makes negative 31. So I'm going to rewrite this side of the equation. Negative 31 plus x equals, and then we can work this out as well. Negative 7 and 12, that makes 5. There you go. All right. And so now it's just a matter of, if you look on the variable side, look on the x side, we can add 31. So we're going to do the inverse of negative 31, which is plus 31. I know there's a plus here, but really we want to negate that negative 31, and to do that, we need to do the inverse of that, which is positive 31. Okay, and so we are left with x equals 36. All right. All right, for example, now this is not the multiplication equation. This is a division equation, which we're going to require an inverse operation of multiplication to solve it. So this is a number divided by 6, right? A number divided by 6 is equal to 16. So the inverse of division is to multiply both sides by 6. That in turn is going to make those 6's cancel right there, right? That's called multiplicative inverse. And then just work it out. So x equals, and then 16 times 6 is 96. 16 times 6 is 96. There we go. All right, for example, J, we're going to do the same thing. Multiplicative inverse of divided by 9 is to multiply by 9. All right, so we're going to multiply both sides by 9. We're going to multiply the left side by 9 and the right side by 9. Keep in mind, the right side is a negative 12, all right? Multiplicative inverse, those turn into 1, right? And all we're left with is A. So we got negative 12 times 9, which is negative 108, negative 108. All right, for example K right here, we got 2/5 x. Now the thing that I always like to tell people to do, and I don't know if I can't remember what I said in the last video, but I probably said this, but when it comes to, whenever there's a fraction next to a variable. I always say when there's a fraction next to a letter, what you should do is you should flip it. Flip the variable, or not flip, flip the fraction, flip the fraction, so 5 over 2, all right? And if you really pay attention to what's going on here, right, that you're multiplying by the reciprocal. And when you multiply by a reciprocal, when you multiply anything by its reciprocal, you end up with 1, right? Those all cross cancel, right? They all turn into a bunch of 1s, right? And we're going to multiply the right side by 1, or by 5 halves. All right, I'm going to write this as a fraction. All right, and I like to, right here, you got negative 14 divided by 2. I like to look at that as cross-canceling that you can possibly do. And negative 14 divided by 2 is negative 7, right? 2 divided by itself is 1, right? And now it's just a matter of just doing negative 7 times 5. Negative 7 times 5 is negative 35. So there it is. So negative 35. Okay. All right, next example here, same thing. We're just going to multiply both sides. I think the thing you have to kind of keep in mind here, and I think the common mistake here when people use the multiplicative inverse is they end up changing the sign. When you're doing multiplicative inverse, you're doing the inverse of the operation. You're not doing the inverse of the sign. Okay, so we're going to multiply both sides by negative 7/3. I know this is negative 3, and you might think, well, why isn't the negative down here? Well, you could. Go ahead and you can do that, but I always like to keep the negative in the numerator. Because, anyway, a negative times a negative is positive, right? We're going to get a positive when we do that anyway. So all this stuff cross cancels over here. It all turns into a 1, right? And so we're going to multiply the right side. I'm going to make that a fraction. We're going to multiply the right side by negative 7/3. Okay, and then right here, these could be cross canceled, right? They could be cross canceled. Negative 36 divided by 3 is negative 12. Negative 12 right there. Okay, and 3 divided by itself is 1. All right, so now we have it. So now we have y equals, and then you just have to do negative 12 times negative 7. Now a negative times a negative is positive, and then 12 times 7 is 84. And that's that. All right. Now on this side here, what I'm going to do is I'm just going to be quiet, and I'm just going to go through these and just, feel free to pause the video, do these on your own. You should really try these out on your own. I don't think we're breaking a lot of new ground on this side of the page of your notes. So try these out on your own, pause the video, then check it with what I'm doing, okay? But I'm just going to be quiet here. I'm just going to go through it, do it, and then we'll be done, okay? I just paused it. I didn't pause recording there. I thought I wasn't recording audio. Oh, you know what? I'm not going to distribute. I'm just going to think of that as 4x. Kind of a weird way to write a problem, but whatever. All right, I'm going to just think of that as negative 4x, and so negative 2 times 4x is negative 8x. And this one I'm just going to speak up on because this one throws people off. I mean, you can always, if you have a negative variable, like in this case, we've got negative x, you can always think of that as -1. You put a -1 there. It doesn't change the meaning of that equation at all. And then that kind of makes it clear as to what you have to do to solve it, which means you have to divide by -1. You have to divide both sides by -1. And there you go. You got x equals -15. Okay. But what ends up happening a lot of times with that kind of problem, is that when people see that, when they see like -n equals, I don't know, I'll put -17 or something here. What they'll do is they'll just go, wait a second, I kind of get this. This negative is going to kind of move over here. And so then it's going to negate the other side of the equation, therefore making it, well, in this case, it's going to make it positive, right? So you're going to get n equals 17. So you can kind of an easy shorthand way of doing that kind of problem. All right, I'm going to divide these. That's 8. And then I'm going to divide by 4. You got 2 equals x. All right, that does it for this section, chapter 7, section 1.